Welcome back to the World Power to X 2020 Summit. Few topics have been as consistently mentioned in the 7 sessions we've had so far than circular economy and climate change. This upcoming session, the 8th session of this World Power to X 2020 Summit, will be looking at one of the most discussed way of combining both circular economy with climate change action. Indeed, carbon storage, utilization, give me a second, carbon capture, utilization and storage is one of the ways that is envisioned in terms of connecting those two important topics. To chair the upcoming session, filled with impressive panelists, I'm happy to introduce the chairman of this conversation. It will be Professor Ahmed Nawi, who is the president of the Scientific Council of IRESEN, the Moroccan Solar and New Energy Institute. He's deeply engaged for the establishment of mechanisms to support and reinforce R&D on renewable energy. He served as head of the research group at HBZ. He has deep expertise in processing materials and devices for solar energy conservation and thin film chalcogenide solar cells. He is author and co-author of more than 200 peer-reviewed journal entries. Professor Nawi, the virtual floor is yours.
Thank you, Chair. Ladies and gentlemen, respected audience, good afternoon. Hello? Do you hear me? Respected audience, as the Chair, he told us now, the carbon capture, utilization, and storage is one of the most important issues to be discussed in this summit. And as you know, I just want to give one word which shows this. The vast majority of hydrogen today is produced from fossil fuel, feedstock, natural gas, and coal, producing a huge annual carbon dioxide emission. And as you know, climate change and CO2 are two things which goes together. So before I give the floor to our distinguished speaker, I would like to remember you that in this session, we have more discussion than talks. And therefore, I will give the floor to Monsieur Ingor Fur-Gudmundsson. I hope I spelled very well.
Yeah.
He is a CEO Carbon Recycling International, by the way, the world leader regarding power to methanol technology. Carbon Recycling International produced renewable methanol from carbon dioxide, hydrogen, and electricity for fuel application, green chemicals, and product. His experienced executive with a background in banking, pension, funds, and managing for other institutions. He has served in several management positions such as marketing director, regional and head office, branch office manager, director for both retail and private banking. The floor is yours.
Thank you, sir. Yeah, good afternoon, and it's a pleasure to be with you at this virtual conference. Carbon Recycling International has been developing CCU and Power-to-X technology and projects for nearly 15 years. I would like to share with you a perspective on the status of the industry, opportunities, and challenges. The root to the climate crisis is our dependency on fossil fuels and carbon emissions, which in turn leads to global climate change, ocean acidification, and urban pollution. Electrification will allow us to reduce our dependency on fossil fuel, but many key industries, such as heavy and long-haul transport, can't be electrified directly and require a growing supply of alternative liquid fuels. The main challenge to electrification is that renewable energy sources are not necessarily located close to the center of demand. For wind and solar generation, we can also not match supply to demand in either time or space. One of the core solutions to the problem of intermittency and stranded energy is to transform electricity into a liquid energy carrier. Our contribution to this solution is a process technology which enables us to produce carbon-neutral methanol directly from CO2 using electricity or byproduct hydrogen as the energy source. Let me briefly introduce our company. CRI was founded by a group of entrepreneurs in Iceland in 2006 to develop a process to transform CO2 directly to methanol. After building the first prototype and raising equity from Icelandic investors, the company built the first industrial-scale production plant of its kind, which was commissioned in 2012. Since then, CRI has been active in the full value chain of e-fuels and became the first company to sell a certified fuel from Power-to-X and CCU in the EU market. Renewable e-methanol from our plant in Iceland has been used across Europe for gasoline blending, fuel cell operation, biodiesel production, and wastewater purification, to name a few examples. Today, CRI is a technology provider for CO2 to methanol technology, working with clients in Europe and China. Our initial plant in Iceland has a capacity of 10 tons of methanol production per day and uses renewable electricity from the Icelandic grid, with CO2 captured from a geothermal power plant. Recently, we have also built 2 demonstration plants in Europe, first in Germany, where we demonstrated the utilization of intermittent wind energy, the CO2 to methanol synthesis system. The second project was recently commissioned in Sweden, where we demonstrated how the technology can be used byproduct from gas from a steel furnace. Our next milestone is a commercial scale CO2 to methanol plant, which we are currently engineering for a client in China. This plant will be 30 times larger than our industrial scale facility in Iceland. The plant in China will transform 150,000 tons of CO2 per year with hydrogen from coke oil gas or 110 tons of low carbon intensity methanol. We are also currently developing a project of the same scale with our partner Statkraft in Norway. But how can CCU be used to decarbonize CO2 intensive industries? The industry that will benefit the most from CCU technology is transport. If you look at the progress made over the last 30 years, it is well known that while power generation and industry have become less CO2 intensive, emissions from transport continue to rise. Many industry players and policymakers hope that direct electrification of transport will reverse these trends. The fact of the matter is, however, that less than 25% of the oil consumed, which goes to the smaller or medium car segment, can be replaced by battery operation in the near term. Large private cars, heavy and long-haul transport by road, sea or air will still require the convenience of efficiency and efficiency of liquid fuels. Let us also not forget chemical manufacturing, which depends on oil or natural gas. These feedstocks will also have to be sourced from alternative sources of carbon in a fossil-free world. In 2009, the EU set a target to replace 10% of the energy used in road transport by 2020 with renewable sources. At the end of 2020 nears, we are still only halfway there. Next year, the target will be raised to 14%, which should be reached by 2030. Further growth of biofuels create its own set of problems. As a result, the EU has decided to cap the growth of biofuels, which leaves battery electric vehicles, waste biofuels, and power-to-X to fill the gap. To meet the 14% target, the supply of waste biofuels and power-to-X by 2030 should be nearly as large as the supply of biofuels today. We must also expect that the 14% target will be raised, as the EU has already decided to raise its 2030 climate target from 40% to 60%. Road transport will have to shoulder a large part of this effort. This creates very exciting opportunities for the growth of power-to-X and CCU over the next 10 years. Another, perhaps even larger market for liquid fuel from power-to-X and CCU is on the horizon. The International Maritime Organization, IMO, has already decided that carbon dioxide emissions from shipping should be reduced by at least 40% by 2030 and by 50% by 2050. The EU is now debating how this target will be met. The marine industry will require a large supply of alternative fuels, considering the need to reduce emissions and natural growth in goods transport, driven by economic growth and international trade. The supply of renewable bunker fuels in 2050 will have to exceed the supply of fossil bunker fuels today. In other words, the alternative fuel industry with power-to-X and CCU in the central role will have to replace the entire marine bunker fuel industry in less time than was passed since the Kyoto Treaty was signed. One of the concerns that we frequently hear is that replacing fossil fuel with power-to-X will require more electricity than is consumed by all other industries combined. The forecast from the German energy agency DENA shows, however, that even if we need to phase out fossil fuels completely by 2050, a combination of solutions such as increased energy efficiency and direct electrification will bring down the total energy demand in road transport. Although the energy demand from electricity in 2050 could in fact match the entire electricity demand in Europe today, the unused potential from wind and solar will be able to meet this demand several times over. Just the potential in onshore wind or utility scale from solar, for example, would supply vastly more energy than needed by road transport. The forecast on the previous slide did not consider any import of power-to-X fuels from outside of Europe. There are, however, obviously opportunities to offshore power-to-X production to locations with favorable conditions for generation of electricity from wind and solar. A study published by Frontiers Economics in Germany earlier this month shows that there are two important reasons to consider this. If we compare, for example, conditions in Northwest Africa such as Morocco, to Germany, we can take advantage of much higher full load towers from wind and PV solar generation, or a mix of both. This increases efficiency, capacity utilization, and hence profitability. There is also another important factor to keep in mind. Although the electric motor is clearly better at transforming electricity into kilometers than the internal combustion engine, we must also take into consideration the efficiency of the entire system, from wind or solar energy to kilometers driven. When we take into consideration the much lower yield of renewable energy in Germany compared to Morocco, the large efficiency gap between the electric vehicle and internal combustion engine driving on Power-to-X fuel in fact disappears. Power-to-X fuel from offshore burned in a combustion engine can be equally efficient way to supply green energy as a battery-powered vehicle. Thank you for listening, and please don't hesitate to contact us by email or through our website if you would like to talk.
Thank you. I would like, before I give the floor to the next speaker, just to point out that for carbon capture, it is important to distinguish between the stationary sources, power plant, factory, and mobile sources like aeroplane, train. And I think you have given very much detail regarding the mobility, the e-mobile, and also the connection to Morocco, to the e-fuel from Morocco. I want to thank you. I want to move to our next speaker is Dirk Nober. Dirk Nober is a process engineer with a PhD in fluidized bed technology. He is heading the Klima Deutschland GmbH, the German subsidiary of Klima Work AG out of Zurich, Switzerland, by taking carbon dioxide out of the air. Klima Work direct air capture DAC technology can reserve climate change. The team in Germany is focusing on project development as well as Power-to-X application. Dirk is a process engineer with a PhD, as I told, in fluidized bed technology and executive MBA IA Business School with focus on entrepreneurship. He has over 20 years of experience in engineering management, project management, business development, and the establishment of team internationally. Thank you, and the floor is yours.
Thank you very much, Mr. Chairman. Can you see the right screen? No, probably not.
It's fine.
It's okay. Good. Thank you very much for having me. I'm very excited to contribute to this interesting discussion. I would like to quickly start with a little overview over Climeworks, which I realize doesn't happen right now. Okay. You see the first slide? Good, excellent, because I'm seeing something different, that's why, so I'm just making sure. So Climeworks is a company with now about 120 people. We have been, or we are probably still a startup company out of Switzerland with a subsidiary in Cologne, founded by the two owners and founders which you see on this picture. So usually I would start the presentation by talking to you about climate change and how important it is to, at least we know this latest since 2018, how important it is to become carbon negative, which the IPCC has said that already end of 2018 very clearly. And that is what Climeworks is really after. We are offering solutions to become climate negative, which I want to present to you at first, and then also talk to you about Power-to-X solutions, which we are working on as well, or we have been working on in the past as well. So our solution is direct air capture, meaning we are taking CO2 out of the air. Very plainly and simple speaking, you see on the left side on this slide, and also kind of behind me on that background picture, our first industrial plant, which is located in Hinwil in Switzerland, which is taking about 1,200 tons of CO2 out of the air every year. The specialty about our technology is that it's a modular approach. So we want to kind of move towards not a normal setup in terms of scaling up, but rather a mass production setup with this technology. And you can see the modules in this picture. Of course, we need sustainable energy as our energy source, and very important carbon footprint. We can't allow our plants to produce more carbon when being built than they can actually take out of the air over the lifetime. That is very important. And then what we're very proud of is that we are the first company worldwide that is actually offering direct air capture solutions to customers, and also products, meaning the CO2 that we produce, for instance, from this plant in Hinwil is sold partially to Coca-Cola. But now allow me to move quickly to one of the projects we are progressing right now in Iceland. The project is based on a technology that is used by Carbfix, also an Icelandic company. So we have two Icelandic activities here going on right now, which is nice. We have a small plant there already for a while, taking CO2 out of the air and pushing it into the ground using the so-called Carbfix method. It's very simple. You put the CO2 into the water which you're pushing underground, and what you actually achieve there with the basaltic rock that is there in Iceland, which you see down there, which is demonstrated here, you actually solidify the CO2, which means after about a year, the CO2 is gone, it's under the earth, and it stays there. So of course, that is very interesting because you can take CO2 out of the air and create a carbon negative scenario that helps with the overall climate change scenario in the long run. This is a picture, or three pictures actually, of our site in Iceland, in Hellisheidi right now. On the left side, of course, still a 3D picture of the plant, how it's intended to be in about early January. So we're building this plant right now, which is about a capacity of 4,000 tons of CO2 per year. And we intend, of course, to get all of that CO2 under the ground with the same method I've just described. On the right, you see two pictures there of the construction progress. And the right picture shows you actually right here the modules, the direct air capture modules, which are going to be located right in front of this so-called process hall, where all the utilities are in to process the CO2 and also provide, for instance, heat for the process. In the matter of only a little time left, I want to move on very quickly to the real topic, to Power-to-X. So of course, direct air capture, you can not only put the CO2 on the ground, you can also use the CO2, as it has been described before, to produce fuels. And what we do, and we have demonstrated this in this carbon cycle, what we do is we take the CO2 out of the air, produce with different types of synthesis methods, usually some sort of electrolysis or co-electrolysis in the Fischer-Tropsch reactor. We produce synthetic fuels together with partners, which can then be used, for instance, in the airline industry, which is so desperately looking for options, especially for the long-haul flight. So with that, you can see from this circle, this is what it really means, that you can produce carbon neutral or near carbon neutral fuel, which you can, of course, not produce from CO2 that has come at one point in time out of the earth from some sort of fossil fuels. So I want to mention to you three important projects there. Of course, there is a funded project by the German government, which is relatively small, as you can see there, but it was the first project where this process chain has been integrated, where we took CO2 out of the air and produce fuels from it. That was happening end of last year. There's a Horizon 2020 project, so-called Store and Go, which most people might know already in the audience. There we have used direct air capture to produce methane. And hot off the press here is what was announced recently is a power-to-liquid project in Netherlands called North E-Fuel, where we, together with partners Sunfire and PowerWord, produce power. Use power to produce liquids. Again, the focus is on kerosene, on Jet A1 fuel. And in the first step, there's going to be a direct air capture plant there, and there might also be some CO2 used then from the industrial area, which you can see on this picture there. Plan is to start this plant up in 2023, which is a milestone for Power-to-X, and of course only a start for further plants which are planned to be built in Norway in the future, then based on solely direct air capture in order to make that fuel completely carbon neutral. Thank you very much for your interest in our technology, and I'm happy to take questions later.
Thank you, Dirk. So before we move to the next speaker, I would like both of you asking you, Ingolfur and Dirk, what can distinguish your two technologies, and if you have any relation together, and in terms of cost for your modular, can you give us some detail that if it's available and it's very easy to get for developing countries like Morocco, and if it's possible in this kind of business, a kind of transfer of technology?
Of course, I mean, we are very open to that. Possible is also dependent on climate conditions and location conditions. The most important thing is that you know where to use the CO2, because there's no point taking it out of the air if you can't use it. So a sink of some sort or use of Power-to-X technology is very important. The technology is, I wouldn't lie to you, is still very expensive. And that's not only the direct air capture technology, that's also the power-to-liquid technology we are using in those projects which I have presented. But that's quite normal with new technology. Nothing has started cheap ever and have become as big as conventional technologies. So we know exactly where we need to go. We know how we want to get there. We need some more time. Right now, the CO2 we produce is certainly well beyond, I would say, $500 per ton, which is, of course, we all know that is not competitive as yet. But as CapEx is coming down, as operating costs and heat and energy consumption is coming down through development, you'll reduce this to a point in the next 5 years where those fuels will become quite feasible.
Thank you. I just want to ask Ingolfur about the relation to Power-to-X in Morocco. You talk about you want to use the fuel from Moroccan industry. Is there any project actually which will be fixed in the future when advanced?
Not currently. We have in the past been focusing on the market in China, and as I told you earlier, we are now commissioning the first commercial scale plant there, and the methanol that will be produced will be sold at market price there. And we are also preparing another project in cooperation with Statkraft in Norway, where we will produce the hydrogen from electrolyzers. And the capex there is much higher because of the price of electrolyzers. So we need to get some funding from EU to be able to work on that. But in China and even in Morocco and India, where we can get the hydrogen as a byproduct from the cocoa gas production or other sources, that it's commercial viable today.
And a last question for both of you. Regarding the deployment of technologies that achieve negative emission, what is the status actually in your companies?
Well, I'll quickly start with that. Negative emissions, I mean, the status is positive. We're doing this already since 2017 on a very small scale in Iceland. We have a small module sitting there since 2017, taking CO2 out of the air and pushing it into the ground. That's the basis for us building this larger plant now. In fact, if you go to our website, you will see that we're selling CO2 certificates, so to say, already on the website. There are a lot of companies, also individuals, but also companies interested in that. And that plant we're building there in Iceland is already to at least 50% sold out with regards to capacity over its lifetime. So I would say it looks very good for us. And with that, hopefully also for the world, that we can scale up this technology rapidly.
Thank you. So we will move to John Moorish. Welcome to this webinar, to the summit. Moorish is a member of the managing board, Western and AMP, Southern Europe at Heidelberg Cement. Heidelberg Cement is one of the world's largest building material companies. He is also responsible for the Department of Environment and Social Governance at Heidelberg Cement. He is going to talk about this topic of capture and use and in the Heidelberg Cement driving business application. And I think the floor is yours. Thank you.
Thank you. Let me just pull the presentation up. Hopefully you can see the presentation now. Good afternoon.
John. Not as yet,
Not
John.
yet.
I
Not
can't
yet.
see it.
Not yet visible. Yeah.
Maybe the other screen.
Yeah.
Yeah, that looks good.
Yes, fine. Fine.
Yeah.
Thank you.
Okay, apologies for that. Yes, thanks for welcoming me. Yes, I'm responsible for Heidelberg Cement's Europe business, but for today, I'm also responsible for our ESG and sustainability agenda. In Morocco, the basis for my being involved this afternoon is we have a very proud business in Morocco. In Ciment du Maroc is our business in Morocco. And have got a long heritage of being in Morocco. Heidelberg Cement have a very ambitious program to be carbon neutral by 2050 at the latest in our cement and concrete business. And as a large industrial company, one of the largest cement companies in the world, we inevitably produce CO2 as part of the process emissions of our business. In all of our 52 countries, we have a very detailed roadmap to arrive at carbon neutrality by 2050. But it essentially focuses on three levers. So you'll see the timeline along the bottom and the potential to reduce CO2 on the left. And we have three key levers that we will apply at different levels in all three areas in our 50 countries around the world. The first is the reduction of CO2 through conventional measures. Essentially, that is reducing and eliminating the use of fossil fuels in our production process, and then reducing the amount of high carbon intensive material, clinker, in the production of cement. And you'll see that that represents currently the majority of the activities that happens in the cement industry. We're here, and it will represent roughly about a third of the ability to reduce all of the carbon that we need to reduce over this time period. The next area is the circular economy that has been discussed in the summit already, but that is the use in our business of recycled materials, and that has a significant potential starting in this decade but going to 2050, and also the introduction of numerous innovative materials in concrete and new cement materials. So that's the second area, and again, roughly another third of the total reduction of CO2 will come from that lever. And then the third area that is represented in blue here is CCUS. Again, we start at the moment and in this decade, and over the next 2 to 3 decades, this will also represent about a third of the potential to reduce CO2. So we need to pull on all 3 of these levers over the next 2 to 3 decades. So focusing on CCUS, we already have numerous projects underway across our business in different countries around the world, and we're quite ahead of the game in this area. In capture and purification of CO2, we are trialing and at quite developed stages in a number of different technologies in post-combustion, oxy-fuel, direct separation in a variety of countries ranging from Canada to Norway to various European countries. And then in usage, which is shown on the bottom area, we also have a number of different projects. In Morocco itself, we have an exciting project where we are developing and produce microalgae for the use in pet food. In hydrogen projects, we are underway in France and in the UK with trials combining hydrogen with CO2. And we're also electrifying our kilns, which takes fossil fuels out from the process. So CCUS is a key part of our CO2 reduction activities in the business. So switching to Power2X, this schematic demonstrates essentially that we see ourselves as being a core partner for Power2X activities, as we have obviously the production of CO2 and the capture and purification of that by the projects that we've currently got underway and other technologies that have been described by Ingolfur, for example, before, and the supply of CO2 in the process that could be combined with hydrogen produced by the other side of the value chain to generate products by a Power2X process methodology. In Morocco, we would see Morocco as a great place for this activity. It's not, I'm not an expert at this, but your outline on the left-hand side that the availability of large amounts of renewable energy, both from wind and solar, is a core starting point. And we would highlight the benefits that we would have in our own business in Morocco, in Ciment du Maroc. We have a long and proud history in the country. We run 3 modern kilns at Safi, Aïd Baha, and Marrakesh. We've got an excellent track record in Morocco in sustainability, and we're already got a highly developed project in carbon usage in algae farming at Safi. And we're backed by a company that really is intent on CCUS as a core lever to reduce CO2. So we have competency that we can bring to Morocco from the rest of the world, and the numerous projects that we already have undertaken in CCUS. So just a few final facts on our Moroccan SAFI project. We take CO2 from the flue gas production process. It's then through photosynthesis, we then develop and grow high quality microalgae for animal feed and aquaculture. Currently, the scale of that project is relatively small, 0.25 of a hectare, and we produce 30,000 kilos per year of microalgae. But that's been during the development stage, and we're scaling that up currently in Morocco. It's just a good example of a carbon usage project in Morocco that I think hopefully demonstrates the focus of the business. And so we are well positioned to discuss and further partner with methods to carbon capture and then use and store and carbon and then partner in Power-to-X projects in Morocco. So self-evidence, CCUS is one of a key pillar for us in our carbon neutral efforts as we take our business forward. That's my presentation to you, and then open for further conversations on this as you open the floor.
Thank you very much. Thank you. So just one question before we move to our next speaker. Do you consider the work in Morocco as a business or a cooperation to increase the capacity of Moroccan industry to get know-how and to be developed? And do you think that there are companies in Morocco which you are involved for the creation of jobs in this Power-to-X and in the cement industry?
I didn't hear the first part of the question, but I think, and so please, could you repeat that?
Yes. My question is, are you considering the work with Morocco as a business or a real transfer of technology, creation of jobs, and development of the industry in Morocco?
I think what I would say on that is, honestly, we've worked on, I think we've got 9 CCUS projects at different stages in different countries, not in Morocco right now. But we've been pushing hard at that to really learn. And back to the earlier speaker, Mr. Nuba, we're trying to understand the costs of technology and the costs of both the capex and the operating costs of carbon capture and use and storage. So we've been doing that elsewhere, carbon capture projects, but in Morocco, the SAFI project has also been done locally. So we've learned from that. So what we're trying to do is learn from the projects we have around the world and then apply the best technology and the best cost for that technology into Morocco. What I would say is our business in Morocco is well established and we're there for the very long term. So what we learn elsewhere, we want to apply in Morocco. And I guess that's why I also showed the project at SAFI. That's a real project. We hope that we can grow the microalgae project in Morocco, and that is a job creation project in Morocco, and then transfer that technology to other countries. So really, for our business, that project is cutting edge, not just in our business, but around the world. And that is something being developed in Morocco that we can leverage elsewhere. So I think it's really a mix of technology coming into Morocco, and then we learn from the microalgae project, and that transfer can go can go to other countries. So Morocco is a key part of our business.
Okay, thank you very much. Thank you very much. So let's move now to Julius Alcon. Did I spell it very good? And Julius Alcon is head of cell and development within Steg Energy Services. He oversees energy technology, business development, sale, and the development of a new business. His activities focus on service and solution along the transition of the energy sector toward decarbonization of the sector. Steg Energy Service GmbH is one of the world leading service provider for power asset. Julius, the floor is yours. Thank you for coming.
Yes, thank you for having me. And I've got a few statements just because we have learned as STEAG, we are currently developing a hydrogen generation project in the south of Germany. And what we've seen there is that the problem is at the moment is not the generation of hydrogen, the generation of blue hydrogen, or if we look into North Africa, the green hydrogen. The current hurdle is the utilization, is to get rid of the hydrogen and to use it in applications that yet need to be developed, and we have heard that. And Dr. Nubar has made a very interesting statement regarding CO2. Once we have captured the CO2, and be it from the air, be it from other technologies, be it from biomass power plants, or even conventional power plants could be a solution, what do we do with these things? And it is important to think about the entire cycle. And one very important aspect to me is that if we look onto Northern Africa, especially also Morocco, with a big potential of renewable energies that has a big potential to produce or generate green hydrogen. So again, what do we do with the hydrogen? And bringing together captured CO or CO2 and then methanizing it, so producing methane or methanol from that, can be used in existing infrastructures. And that, I think, is a missing link, or is at least one important point to boost the hydrogen generation, which is technically feasible at the moment, is to solve the problem of the missing link. And the missing link to export the hydrogen from, for example, Morocco, is that there is no hydrogen infrastructure. There is no hydrogen ships. That all needs to be invested and built up, which is a big investment needed, and so big efforts needed, and also a lot of time needed to have that. So bringing, again, another reason to bring hydrogen together with CO2 to methanize and then use existing infrastructure, for example, of LNG, for example, of just pure gas, natural gas that can be used locally in chemical plants, and that can be transported in an existing infrastructure to other countries, as for example Europe. And the second aspect I want to mention is that scale is of importance. If we look about the potential to substitute the H2 that's currently needed in the chemical sector just in Europe, we have a potential of roughly 700 terawatt hours of hydrogen that can be utilized in Europe, all over Europe, in the chemical sector, petrochemical chemical sector, but also, of course, in other sectors like mobility. And again, a carbon capture in a larger scale can help to solve this problem if we produce green hydrogen. And I think it's just an important missing link to utilize existing infrastructure to boost the generation of hydrogen and the use of hydrogen. Thank you.
Thank you very much. First of all, thank you for this summary, because you summarize exactly the point which we have to work on it. Regarding all this point, I think, first of all, carbon dioxide is a problem of the whole world, is a global problem. And therefore, the international cooperation is very important. So if we want to have infrastructure in Morocco, we have to do it, if we want to do it faster, we have to do it through cooperation and international collaboration, in my opinion. I think the hydrogen, if we have hydrogen, what we have to do with, I think the half of the answer is we can use the methanation, the Haber-Bosch process to make, for example, ammoniac, which is for fertilizers, are all. But the most important point, in my opinion, is to the scale up, to reduce the cost, and how to scale up. We have to do it just through the cooperation, and only countries like Germany, the other countries in Europe like England, they can help because they have already part of the technology. And I think if we want just to focus on Morocco, we need more cooperation in this Power-to-X and fixation of CO2 and the transformation of CO2 into other
Chemicals.
sustainable products. And it has to be win-win. Morocco will benefit, Europe will benefit, and Morocco is the door for Africa. And in my opinion, every country, they try to cooperate with Morocco and to invest in Morocco. They have also Africa. They are in the door and they can go there, in my opinion. So I will open this discussion where every keynote speaker can say something about these issues, and afterward we can give the floor to the organizers. So please, Herr Igor, I thank you first for giving your talk. Herr Dirk, Herr John, you, Georgios, if everyone can give one word about the future of Power-to-X and fixation of CO2 and the use and storage. What do you think in the future can happen if there is really this international cooperation, and what the benefit we can have? When I talk about Morocco, I talk also about the whole Africa. So can we have?
I could make a comment. I could make a comment back on your last point, Dr. Enoui, on the scale benefit. I agree. And just to give some context, we talked about carbon capture in the cement industry. We have a project in Norway that will be the largest industrial scale project that will be capturing and moving and storing carbon by 2024. And it will do about 500,000 tons from the cement plant there. It's the first industrial scale CCUS project. But to your point, a lot of that money comes from the Norwegian government. And it is within the scope of the EU ETS. So we learn a lot from scaling up from the projects that we have underway in Europe and also across in Canada that then can be applied at industrial scale when we have made that learning in partnership and cooperation and transfer that into Morocco. So I think that is happening quite quickly. And so I guess my point is that I agree that Morocco can significantly benefit from the work already being done elsewhere and happen quite quickly.
Thank you. So, other speaker, do you have?
I think maybe just the only thing I can say is that for us, Morocco or Northern Africa, by all means, to take it a little broader, is an area that is a no-brainer for direct air capture, and of course then for Power-to-X activities. We have always looked at that. We have quite a few projects in our project development funnel looking into this. And I will just compare it with, there has been an announcement today or yesterday that the German government is supporting a project in Patagonia, to produce methanol. In this case, from wind. In my mind, Patagonia is the wind powerhouse, just like Morocco or Northern Africa is the solar powerhouse. So there's absolutely no reason why the same project could not happen in Northern Africa. Why it is in Patagonia right now, I don't know. There might be good reasons for it, maybe because there are methanol plants already down there. But I'm pretty sure that those projects will happen in the future. I mean, we have certainly planned for them.
Thank you.
Yeah, I just want to add that, sorry. I would just want to add that for those who really are interested in carbon neutral future, Power-to-X and CCU must be a part of the arsenal. And I think also, like I was mentioning regarding Morocco, that incentives within the system must be based on a holistic view of the whole value chain from well to wheel. So definitely you have a lot of opportunities in Morocco.
I would fully support that, and I would agree to Morocco being a very good starting point because of the proximity. So if we look from Europe, of the proximity to Europe, but also looking into Morocco, one aspect would be of course the sources of solar energy, but also Morocco has quite a remarkable industry. We have John Morris here, so that's an industry. We have the petrochemical plants, the phosphate plants in Morocco on the western side. So there is a lot of potential also to develop local solutions and develop local supply. And in the same time, Morocco is on the seaside, so also to use the potential for methanized hydrogen is there to export it. So I think that it's a very good starting point. And if coming back to Monsieur Enaoui, then also opening doors to Africa.
Okay, thank you very much. So we had a discussion which is, of course, very important, but a little bit business-oriented. And I am thinking about Morocco always. However, we have here 4 questions which are a little bit more general. I think we have already discussed it, but if someone can give some issue, he's welcome. I will read the questions which we have here on this flyer. How can carbon capture use and storage be as a key tool to help decarbonization of CO2 in the industry? What is the role of CCUS in mitigating climate change? This is, of course, depend on the whole world. What are the market predictions for CCUS, and what are the challenges facing CCUS? I think we have already discussed this, but if you have something to say, please go ahead.
Yeah, the first challenge is demand uncertainty. Fundamentally, it's a chicken and egg problem. Fuel distributors lack the incentive to sell alternative fuels, and car manufacturers lack the incentive to build cars which accept greener fuels. And automakers need to benefit from producing cars which operate flexibly on alternative fuels. This will in turn provide strong incentive to fuel distributors to increase demand for alternative fuels.
Okay, thank you. So is there any other questions? Otherwise, we will give the floor to the next session. But I want to thank you, all of you, for this very important session. It's one of the key sessions because we talk about Power-to-X and connected to the CO2, which is the big problem, the big challenge. So is there any last word from the speaker?
I was only going to say to you from the last point, look, from an industrial point of view, CCUS is extremely important. It's not a sideshow, it's very core. And we need to balance and get more use cases for the carbon. So Power-to-X is an extremely good use case, and Morocco is in a good position, as Julius was saying. So I would echo those facts. So I think it's a relatively positive future outlook, not a negative outlook.
Okay, thank you so much. Thank you for this nice discussion, and hope to see you in Morocco live next time, real, in a big conference, and to visit also Irizen to see what is done there. So the floor is now for the moderator, and sorry for this small delay.
Thank you very much.
Thank you very much, Honorable Chairman, for this particularly interesting session. Thank you, of course, as well for always thinking of Morocco. Morocco definitely has an important role to play as a key facilitator and stakeholder in a strengthened relationship between Europe and Africa, for example. We heard about specific levers for carbon neutrality in the cement industry. We heard about other opportunities and solutions provided by our series of experts, and it was particularly appreciated by myself, and I'm certain by all the participants. At this point in time, I'll be very happy to announce that the next session will be a dedicated session led by DII, where we'll be discussing a topic that was announced in a session earlier today, which is the MENA Hydrogen Alliance. We'll be reconvening in 15 minutes. Thank you very much for your attention. Looking forward to see you again in 15 minutes. Take care.